Tricia Rand, pharmacology instructor and paramedic program director at Ames Community College. Today we're going to learn about concentration. Not the kind that makes your brain hurt, but the kind that allows us to calculate how much drug is in a solution. It's important to understand concentration in order to solve drug infusion problems involving things like lidocaine, epinephrine, and dopamine. So let's say you're famous for your recipe for cranberry juice spritzers. Your recipe calls for a glass of cranberry juice mixed with 3 tablespoons of orange sherbet. Yum! Tomorrow you're going to throw a party for all your friends, and you know that they would love some of your yummy drinks. But instead of spending all night in the kitchen making individual drinks, you decide to make a whole punch bowl. It is important that the drink in the punch bowl tastes the same as your original recipe. Your punch bowl holds 64 ounces of liquid. So how much cranberry juice and orange sherbet will you need to make the recipe in the punch bowl? Remember, the recipe calls for a glass of juice, which is 8 ounces, to 3 tablespoons of sherbet. Let's start with the cranberry juice. We're going to need 64 ounces of juice, and since each glass is 8 ounces, that would mean we need 8 glasses. I got that by dividing 64 by 8 to get an answer of 8. How much sherbet will we need? Since we normally mix 3 tablespoons per glass, and we're going to use 8 glasses, it makes sense that we will need 8 times as much sherbet. So 8 times 3 equals 24. We will need 24 tablespoons of sherbet. So if we made the punch correctly, it should taste just like the individual servings we made before. Why is that? Because the concentration of juice to sherbet is the same in the individual servings as it is in the punch bowl. You could also think of concentration as a ratio. In this case, the ratio is 1 glass to 3 tablespoons, or 1 to 3. Now let's mix up a delicious batch of, say, epinephrine. You may want to make a batch of epinephrine if you wanted to slowly deliver the medication to a patient with anaphylaxis, or maybe a cardiac patient. We're going to mix 4 milligrams of epinephrine into a liter bag of saline. Remember, a liter of saline is really 1,000 milliliters, so the ratio, or the concentration, is 4 milligrams to 1,000 milliliters. It is best when we're talking about concentration to reduce the ratio down to 1 milliliter instead of 1,000 milliliters. To do this, we need to also reduce the 4 milligrams to micrograms. Remember, 4 milligrams are the same as 4,000 micrograms. So let's look at it this way. The ratio is 4,000 micrograms of epinephrine to 1,000 milliliters of saline. That can be reduced to 4 micrograms in 1 milliliter. So the concentration of an epinephrine infusion is 4 micrograms per milliliter. In reality, we don't usually mix up epinephrine in a liter bag of saline because we don't want to give our patients too much fluid. This could cause pulmonary edema, which is bad. Instead, we cut down the recipe to mix it in a small 250 milliliter bag of saline. To cut the recipe down, we are going to mix just 1 milligram of epinephrine into a 250 milliliter bag. This is the same thing as mixing 4 milligrams of epinephrine into a 1,000 milliliter bag. This way, we are keeping the same concentration of 4 micrograms per milliliter, but making a smaller batch so that we don't give our patient too much fluid, which could lead to pulmonary edema. Let's try applying these same principles to lidocaine. What concentration would you have if you mixed 1 gram of lidocaine into a 250 milliliter bag of saline? This would be the same as mixing 4 grams of lidocaine into a liter, or a 1,000 milliliter bag of saline. The ratio in this case would be 4,000 milligrams of lidocaine to 1,000 milliliters of saline, or 4 milligrams per milliliter. How about this one? If you mixed 1 gram of lidocaine into a 500 milliliter bag of fluid, what would the concentration be? This is the same as 2 grams of lidocaine in a 1,000 milliliter bag. If we reduce it down, that is 2,000 milligrams per 1,000 milliliters, or 2 milligrams per milliliter. So you see, concentration in pharmacology isn't so difficult. It is as simple as knowing how to take a recipe and increase or decrease it to make a larger or smaller batch. Stay tuned for more AIMS paramedic pharmacology videos. If you're interested in a great paramedic school, visit our website at www.aims.edu.